Okay, and here we have question 5. So this question concerns elements in group 1 of the periodic table. Group 1 elements are stored under oil. Suggest why. Okay, so this is to prevent them reacting with moisture in the air. Okay, explain why group 1 elements are called alkali metals. So when they react with water, they produce alkaline hydroxide compounds. As a full answer, you would probably get credit for simply saying they form alkalines when they react with water. Okay. Lithium, sodium, and potassium are the first 3 metals in group 1. When a piece of potassium is added to cold water, it melts, moves around on the surface, and burns. Give the flame colour observed in this reaction. Well, this is normally when you see it in a demonstration, you would describe it as pink. However, we do like to use the word lilac. So the flame is a lilac colour. It's very distinctive for potassium. And it says, write a word equation for the reaction between potassium and water. Include state symbols. Okay, so a word equation, as it says, is for the words. So it'd be a good idea to start with potassium. And potassium is a solid, and that reacts with the water. Okay, so it says potassium and water here. These are the reactants. And those two things react together. And we just said previously that when they react with water, they produce alkaline hydroxide compounds. So we would expect to see potassium hydroxide. And the metal reacting with water produce hydrogen gas. So that's the other product of this reaction, hydrogen, and it's the hydrogen that burns. Okay, lithium lies above sodium in the periodic table. Give 2 similarities and 2 differences between the reaction of sodium and lithium with cold water. So similarities, they both float on water, and they both fizz. Now, sodium can be convinced to set on fire, but it takes a little bit of convincing and a big lump of sodium. So they do both fizz, which are similarities, and then differences. The sodium, it gets so hot it melts, and we see that as it melting into a sphere. Okay, and then we could comment on the difference in reactivity. The sodium fizzes more vigorously. So that's 2 similarities and 2 differences. Okay. And then the final part of question 5, write a balanced symbol equation for the reaction between sodium and water. So this is towards the end of the paper, so traditionally exam papers become more difficult towards the end. So a balanced symbol equation, we'd need to look up sodium. Okay, so sodium is here, so that's Na, and Na is a solid at room temperature. And then water, I think most people might remember that water is H2O. That's the the reactant, that's an L for liquid. And then the product of this reaction is a metal hydroxide, and the metal in question is sodium. So that's NaOH. Even though it's a hydroxide, we usually write the formula as OH rather than HO. And that is aqueous, it dissolves in the water. And then, of course, we get some hydrogen gas. So if we have a look at this, there's a number of methods we could use. But one quick method with the space provided would be to use little dots. So dots here, that dot represents how many sodiums we've got present in this equation. Because there's only one sodium with no numbers, there's one dot. Hydrogens, we've got two hydrogens there, and we've got one oxygen. Okay, so it's a 1 to 2 to 1. On this side, we've got one sodium, an oxygen there, and then we've got three hydrogens altogether. So I'll put the dots under here, okay, to show that we've got three hydrogens. So at the moment, we've got a bit of a problem. So if we've got three hydrogens on either side. So what we need to do is if we double this, this, and this, that will give us two sodiums. It will give us four hydrogens and two oxygens. Then we'll get two sodiums there. We'll get one extra oxygen there, and then we'll get another hydrogen there. So if we have a look now, we've got two sodiums here, two sodiums here. We've got four hydrogens here, and we've got four hydrogens here, two oxygens there, and two oxygens there. So that's the finished product. Okay, that's the finished balanced equation. Rubidium lies below potassium in group 1, suggests how its reaction with water would be different from that of potassium. It would be more reactive, as the group 1 elements become more reactive as you go down the group. Could say it might explode. Rubidium is very, very rare on the Earth. There's not a lot of it and very difficult to extract. And then give one safety precaution taken when adding a group 1 metal to water. So you could add a safety screen for pupils observing the reaction. You could mention wearing goggles. You could say small pieces of metal. Okay, you're not given a large chunk, you're just given a small piece. Okay, so they would be three examples of safety procedures.